Hey guys, today we'll be looking at another build your own battery kit, this time from EEL Battery. I love these kits. They come with all of the components you need. A BMS, bus bars, cabling, epoxy board down to every last screw and bolt to assemble your battery. This allows you to purchase cells from a distributor of your choice or to repurpose them from another project. Let's take a look at what this kit includes and then we'll run through the full assembly process. For this build, I will be using these EVE 230 amp hour cells. These are the LF230s. I purchased these from Shenzhen Basin approximately, I think it was around 2021, August of 2021 when I ordered these, if I'm recalling correctly. So they were in service for about 2 years and then they sat for about a year. This is a great way to repurpose these used cells that have otherwise just been sitting around. This kit measures 16 1/8 inch in width, it measures 10 inches in height, and it measures 21.5 inches in depth. So I took the lid off and removed some of the screws and you can see the components it comes with on the top. Each one of these will attach to one of the bus bars or cell terminals. Then they've got this PCB that routes them all up to the front where they have a connector or two different connectors it looks like. And here's a quick look at the bare bones chassis before any components are mounted. There's not a single screw in this thing yet. We've got 6 long epoxy boards. I assume these are for the bottoms and the sides. And we have 4 smaller epoxy boards, which I assume are for both of the ends. This appears to be our BMS here. This should be the JK BMS. Yes, this is a JK BMS, 2 amp active balancing. We've got the actual BMS here. I've not actually used a JK BMS before. I know a lot of you guys talk about them, but believe it or not, I've not used one, so this will be a first for me. We've got a module with the communications ports, the balance leads, and a ribbon cable, and I assume this is for the relay on the front. There's a lot of stuff in this box. Here are the remaining epoxy boards, and there's foam. You can choose between epoxy board or foam. Look at that. So we've got our foam and epoxy board. This is the, a handle, that's a handle, and a second handle. We've got some flexible based bus bars or interconnects. I assume these go to the circuit breaker and the BMS based on their size and formation here. Positive and negative terminal. Large pack of bus bars, and one thing I noticed with these bus bars is they all have holes drilled, threaded holes. They're actually holes with inserts for the BMS leads. I am glad somebody finally adopted this design. A lot of what I was seeing was putting the balance lead on the same terminal as the battery stud, and I've pointed out for a long time that it's optimal to have those balance leads on the bus bar and not on the same terminals. And I am glad to see a company finally adopted that design. And I'm gonna have to go see if I can actually purchase these bus bars separately, because now I'd like to use them in my own battery builds. These are the balance leads for the PCBs. Oh, another handle. There must be 4 handles. Yep, there are 4 handles. Insulated foam for the top of the batteries. A 250 amp. It appears to be a 250 amp DC rated circuit breaker from 12 to 125 volts. And it does feel like a DC rated circuit breaker. You can tell they've got a certain springy feel to them when you use a DC breaker versus a standard AC breaker. We've got 2 latches if you're going to stack multiple of these cases together. I believe this is a dust cover for the circuit breaker. We've got a bag of terminal screws for the batteries. We have a case of various type hardware, gaskets for the terminals, and I think these are just knockouts from the insulation. We've got covers for the terminals, and what's in this one here? Let's see. Oh, that must be the display for the front for the BMS. This is the BMS display and associated cabling. So we are going to be busy for sure. There's a lot of hardware and a lot to figure out where it needs to go. All right, so I've got all of my parts and tools laid out here. Cells and all the components are on the right side there. And based on the instructions here, it looks like we'll be assembling most of the front-facing components first. So I've removed the front panel from the case. First up is the BMS display. And there are 2 brackets that go over top, so I need to remove the 4 screws around the perimeter. Like so. Next up is the push button switch for the front. Simply remove this nut, and that'll go through the top hole here. Next we have the communications cable for the display and the power button. The larger connector goes in the side of the display, and then the 2 red and black connectors just clip together for the power button. Next, we're ready to connect the circuit breaker and the bus bars. However, it doesn't make note of which direction this breaker should go in. I can kind of figure out which way these bus bars go, but I'm not sure if that plus should be connected to the battery side or the power side. I'm going to assume the battery side, and that will put this 90-degree bent bus bar on the left side, which is where the terminal will go. And that will then put the twisty bent one here on the right hand side. And this will make more sense once I show you how it fits in the case. there are no torque specs given for these bolts. Unfortunately, I don't see it on the chassis anywhere. I'm just sort of tightening them based on experience. So then that breaker will fit in the opening like so, which will then attach to our terminal on the left. That's going to be our positive terminal. And then this will go out to our BMS, I assume. I hope that's in the right direction. I don't see how it works in the other direction. So then this little bracket goes over top of the circuit breaker. It should clip in. Then we'll take our circuit breaker protector cover here on the front, and these screws will simply thread in from the back and hold everything together. Once that's secured into place, we have this little thumb screw here that goes in the front of the circuit breaker just to hold that cover into place. Now there is a latch here, but I suppose this is just an extra level protection to prevent that breaker from being bumped. Next is the positive terminal, and for that we'll need one of these larger screws and 4 of these screws. Gasket goes on first. Slide it through from the front. 4 smaller screws in the front. Here's how that looks from the front. On the back side, we'll put the large bolt through. So it doesn't really give a torque spec for this, so I'm just going to, again, tighten it by experience, and unfortunately, I don't have a better answer for you. Feels about good. It would be nice if they gave torque specs for these bolts, and we'll install the negative terminal the same way. And I actually made a mistake here. The pictures show the negative terminal in the horizontal orientation, and I have it in the vertical orientation, so I need to rotate it 90 degrees. Next is the communications module, and to secure that we will use 4 of these smaller screws. Now I'm not sure actually if I'm to use these ones, or there are some smaller ones in here that are slightly longer than these ones. These longer ones go for the JK BMS. I don't see anywhere else these smaller ones would go yet, so I'm going to assume I use these ones. Oh, you know what? I bet these are used for the balance leads on the bus bars. These are the balance lead screws. See, sometimes talking through it gives you the answer, so I need to take those out and put these smaller ones from this compartment in. With that sorted, we're ready for the communications cables, a smaller white connector, a larger white connector, and a ribbon cable. And with that, we're complete with the front panel, and we're ready to take a look at the cells. First, we will put in the epoxy board. On the longer sheets, the thinner pair will go on the bottom. And then of the wider epoxy board, we'll put 1 on each of the 4 sides. Of the 4 smaller loose sheets, 1 will go on the back of each row. And then we'll save the 2 remaining ones for the front once we have all the cells in. Now the instructions give a very specific layout for the positive and negative that's going to make everything fit together correctly. So it's important to follow this layout. Additionally, it wants a piece of epoxy board and the EVA foam between every cell, so it's not one or the other. We're going to orient this the way of our case, and we're going to start at the top left. It wants the positive on the top left. Now, these foams are adhesive, so I guess the idea is you would peel this off and then stick it to your cell. I'm just going to set them in there. I'm not going to stick them in case I want to pull them back out for any reason, or, you know, use them later for something, I don't know. So 1 foam, 1 epoxy board. The positive is in the top left. For between the cells, I'm going to use the epoxy board that's in this pack here, this multi-pack. Epoxy board, foam, cell, 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 epoxy board, foam, cell. Now for this last one, this front does come off. There are 2 screws here to remove that. Epoxy board, foam, cell, foam, epoxy board. I don't think there is any way this bracket is going back on. There is about 1 inch there of space to make up for to get this bracket to go on, and there's no way there's 1 inch worth of space in here between these cells due to expansion. They look perfectly fine. There's a little bit of space in there, but they are perfectly fine in my opinion. Not enough to make up for that space. So what I'll do is just remove all of that foam, and I'll simply use the epoxy board between the cells. I like the idea of the foam, but I don't see there's any way it's going to fit in here. It's possible this was designed for a different size cell. I'm not 100% sure, I can't say that with confidence, but it does not appear to fit with the foam with the cells I am using. With all of the foams removed and using just the epoxy board, we now have a perfect fit here. The cells are fixed in place. They are not squeezed or compressed. There is a little bit of space between them. As I said, there's a little bit of space in there. However, here are the 9 pieces of foam. They make up approximately the 1 inch we were seeing, and you know, of course they will compress, but there's no way to squeeze these in completely, and even if you did, even if you squeeze these in completely, in my opinion, that kind of defeats the purpose of the foam. So we'll plan to go without the foam. Now we can screw on the front panel to hold the cells in place, and for that we'll be using these screws here in the left-hand corner. So next I'm going to very carefully check every cell and make sure it's in the correct place according to the diagram, and make sure I did not make any mistakes. I've checked all the cells and verified they're in the proper order, so next we're ready to put our bus bars on. And this diagram indicates every place a bus bar should be placed. So I'm going to very carefully run through and place all the bus bars. And this larger one here with 2 holes will be the one for the top here that goes across the battery pack. I'm going to leave that off just for the time being. Next, we're ready to put all of the nuts on the bus bars, and these are 6mm serrated flange nuts. We have 16 cells at 2 terminals each, is 32 nuts. Now that all the nuts are hand tightened down, the instructions indicate 5 Newton-meters of torque, which is approximately 45 inch-pounds. So I'm going to go through them one by one and make sure they're all torqued correctly. I'm ready to put the top brackets into place, but before I do that, I need to apply the foam to the bottom as the insulation layer. Once that's done, the connector part will go towards the front. 1 through 8 is going to go on the right side, and then 9 through 16 will go on the left side. Probably could or should have done this before I put the bus bars on. Didn't think of that at the time. And then to secure that into place, we'll use these 4 screws here. Next, we're ready to go through and connect all of the balance leads. So I'm going to start with cell number 1 here. Cell number 1 is the first cell, the first negative post. Since we don't have anything connected to that post just yet, we're going to skip that one and go on to cell 1 positive. So cell 1 positive will go to the first terminal screw on the bus bar. Cell 3 will go to the third bus bar, and so forth the entire way around the battery pack. And for that, we'll be using these tiny M3 screws. And as we're going around, some locations will have a temperature sensor. It looks like this. There are 1, 2, 3, 4 temperature sensors in this case. So where we have a temperature sensor, I'll likely put the balance lead down first and then the temperature sensor. That way the balance lead is in direct contact with the bus bar. I have a couple of tips for you. Number 1 is get a pair of insulated gloves. Now these are from Lifetime. Lifetime actually sent these to me as a Christmas gift. They are wonderful for this sort of thing. These are very close together, so if you're in here holding this lead down and trying to tighten one of these screws, you can see how my arm is bumping against this terminal. It's very easy to accidentally get hurt. And that is why I purposely left this one for the end, because these 2 battery packs are not connected. Okay, last bus bar at the end. All right, and there's the final connection point. This is now a 48 volt or technically a 51.2 volt nominal battery. So across these 2 posts down here is going to be the full pack voltage. So I need to be very, very careful going forward. Now we're ready to mount the BMS, and that will go with this large inductor coil on the top right, directly on top of the 6 standoffs on the front of this case. That'll be mounted with the long screws in your plastic kit. Now I'm making one small change here, and I'm leaving out the 2 screws in the center. There are 3 screws each on the left and the right, so 6 total, and the reason for that is when I put in these center 2 screws, it is pulling the BMS in just a little bit. It's a tiny fraction of an inch, and I did make sure this bracket in here is tightened correctly, so I don't think that's the problem. So I'm just going to mount it with these outer 3 screws on each side and just leave these center 2 out. So next we are ready to connect our balance leads. The black will go in the black connector, is over here, and the white will go in the white connector. And then the instructions say to connect them from left to right, which is the standard way to connect a BMS. And that is starting with the lowest potential and working up to the highest potential. We can see on the left we are starting with B1 and we're working up to B16. And these are labeled, so this says NTC1, and we have NTC2, and so forth. 1, 2, 3, 4. Next we're ready to connect the battery minus terminal to the battery minus of the BMS. And for that we're going to use this stair-step designed bus bar here. There are 3 terminals on the top for different style cell designs. So I assume these 2 are for the EVE 280 amp hours that have that double hole design. And this left one is likely for the single cell design. And then the part with 2 holes goes on the front of the BMS. So you may have to bend this just a little bit to get it into position. And again, I'm using my gloves here since I'm starting to work with a slightly higher voltage. All right, so I had a little bit of difficulty with this last bus bar, and you can see I bent it up quite a bit there. The problem is that the hole I used, it really needs to have another hole like back further here. When I tried to tighten it down as it was designed, kept pressing into this edge piece here, and I did not like to see that. That to me is a point of failure. It's a point where this negative may come in contact with this case here if it ever eats through this insulation. So I bent it quite a bit there, so it's not actually resting on that case anymore. Now perhaps this wouldn't be a problem with the LF280s. They're actually a little bit taller because you've got the thickness of that terminal on top, but I think this is just because of the type and age of cells that I'm using. So I did get it connected there. It is bent up a little bit, but it should get the job done well and in a safe way. So before I do that, I need to connect the communications ports. So we have one ribbon cable. We have a smaller white connector. The smaller one goes in the center. And we have a larger white connector, which will go on the right side of the connector lineup. We then have this little tiny one here for the display, which will go into this port down here. Not sure what it's labeled because it is Chinese characters, but it is the only port that this plug will fit in. Now, we have this red wire here to supply power, positive power to the BMS. And the positive terminal says battery plus is down here. This wire is soldered, is tinned on one end, and has a ring terminal on the other. And this is a screw down here. So what I really need is a wire that's got 2 ring terminals. And I think that's a mistake because everywhere I look at these pictures, it shows that positive wire hanging off the BMS as if it's soldered to the board and not connected via a ring terminal. So I just used one of these guys. Fortunately, I have quite a few of them from past projects. And I crimped it on like you see here. And this is the correct tool that is used for that. It's one of those B-style crimpers that crimps both the insulation to hold it in place and then crimps the stranded wires. So I can connect one end down here now, and the second will go to the main positive. I'm also ready to connect this long bus bar to the main negative, the C- of the BMS, which goes to the front terminal. But before I do that, I'm just going to put a piece of tape over this end here, since most of this stuff is live at this point. Less room for mistakes. Remove these 2 screws, okay, and simply tighten them down. With all of those cables in place and everything double checked for tightness, we're now ready to put the front plate on. So that will simply swing up like so, making sure not to crush anything along the way. And that will be secured with some of these screws you see here. All right, so I did a few things here while the camera was off, and it was tricky getting some of this stuff lined up. So you can see I have the main positive here connected. It's tightened down, and I have both the balance lead and the battery plus for the BMS connected to the same terminal stud there. And you can kind of see how I bent and organized some of these wires now. I did have to bend this main negative a little bit. You see it's not fully connected to this terminal yet. It was pressing into the back of the power switch here, and I'm actually afraid I may have damaged some of those wires with how they were bent. So we'll see if that works once I turn it on. If it doesn't, I may have to repair that. And again, there you can see how some of those conductors are bent. It's not the best way to do it. I like the flexible bus bars for the terminals for sure, but I'd almost prefer to have standard silicone insulated wires for these internal connections. This one's fine over here, but definitely for the negatives and the positives. I don't have the front entirely screwed on yet. I wanted to test it before I go through that, but so we can pull off this protective cover here, and I should just be able to turn it on. Got lights and oh, there it goes. It actually worked. And it says 51.22 volts. Let's see, I haven't checked these cell voltages since I decommissioned them probably about a year ago now, so let's see what they're sitting at. We got most of them, they're all at 3.2 except for this red one's at 3.19. That is pretty darn good. So next we need to make a couple of changes to our BMS. So to do that, I installed the JK BMS app on my phone. Once the battery's on, we can see it in our device list here. It's going to ask for a password. The password is 12345 Pair failed. Let's try again. 12345 Pair. That is what it says the password is here. All right, so Google says it should be 1234. All right, there we go. So it's 1, 2, 3, 4. The instructions indicate we need to make sure it's set for lithium iron phosphate and the correct number of cells. So let's go down under settings. At the top, we want to click verify password, and that's where we put in 1, 2, 3, 4, 5, 6, verify. Now we can click lithium iron phosphate at the top here, and we see it's set for 16 cells. It does still give an alarm, so what is the alarm for? Maybe we need to restart the BMS once we program it. Press and hold. Turns off, and let's turn it back on. And we still see one alarm. And the screen's not showing any alarms. All right, so I figured out the alarm problem. It wanted me to change the default password on the BMS. So to change the password, I went to settings. I then went to the modify password button at the top right here and entered the current password and picked a new password. And as soon as I did that, it cleared the error from the screen. So I don't know why it couldn't just have an alarm down here that says change your password or something obvious like that. But a couple of remaining items we haven't covered yet. The handles, there are 4 of them. They are mounted in this orientation on the side of the case using these small black screws in your kit. Additionally, we have a latch for each side if you have multiple of these cases and plan to stack them. The springy latch would attach like you see here, and then this smaller clip would go down on the bottom. We also have these rubber feet which go on the bottom of the case in the 4 corners. If you choose to stack multiple of these cases together, the feet from the next one would line up with these holes. And then lastly, we have this little Ethernet cable here, which again is a communications cable if you choose to stack multiple of these together. All right, that's where we'll call it quits with this one. This is the EEL 16S 48 volt or 51.2 volt DIY battery box for 230 amp hour cells. Everyone always wants to know price, and I haven't really been quoting prices because they seem to change constantly, but as of the time of this video, this kit sells for $569 and it does ship for free. They do have slightly cheaper versions with a 150 amp BMS or without the display if you want to take a step down. But this kit as it stands is nearly perfect. The only thing I would change as a DIYer is probably using a silicone insulated wire off this main negative terminal instead of that bent bus bar. But yeah, if you have any questions or comments, please leave those. Hit that like button before you go, and if you made it to the end of the video, thanks for watching.